Hello, this is Martha from the Academic Support Center. This is a continuing video for our Calc 1 review. We're going to be going over problems 5 and 6. So let's start off. Problem 5 says, sketch the graph of the derivative for the function shown. Now, if we remember that derivative is a slope, that can make this a lot easier. So let's put up our x and our y-axis. And we'll start looking at this first function. We have a line, and the slope is pretty consistent, where it's a negative slope and it goes down by 1. So if we put -1, we know that we can kind of graph from about -2 over the derivative of this piece of the function is going to be -1. Now let's look at the middle, the second part of the function. This is a cubic function. So if we have something cubed, our derivative is going to be something squared, or a parabola. So that's how we know the shape. And we can see at around -1 that it switches. So we can put -1 there, and then graph our derivative as such. The last part of the function here, we can see that our slope from about 3 down to somewhere in between 4 and 5, our slope here is negative. So our derivative is negative there. And then it switches from negative to going positive. So that also tells us that it's going to cross the x-axis at that point. So if we put a 4 and 5 in, we know that the graph for this derivative, about 3, it's going to go up because it's negative. It crosses the x-axis and then it becomes positive. So it's going to look something like that. All right, on to problem number 6. We've got 6 parts here to do as well. So let's get cracking. We are told to find the derivative for a. We have x cubed and then another function. So right away we know that we're going to be using the product rule. And the product rule says that we have f prime g plus g prime f. Basically we take the original and the derivative for each part. So let's list those parts. We've got f as x cubed, f prime, if we take the derivative of that, that's 3x squared. And then g is going to be tricky. G is x to the 4th plus 5, all of that raised to the 7 halves. Now let's take g prime. We're going to have to do a little bit of cleanup work here. So we bring that power down. We use the power rule. So it's 7 halves, and subtract 1. X to the 4th plus 5 to the 5 halves. But then we also have the chain rule. And so we multiply by the derivative of the inside, which is 4x cubed for the derivative. Now we've got a 4 and a 2 that can cancel out. So this becomes 14x cubed times x to the 4th plus 5, all raised to the 5 halves. So we've got our f prime and g first. So we take 3x squared times x to the 4th plus 5. All of that raised to the 7 halves because that's our original part of that function. And then we're going to take our g prime f and we're going to clean this up a little bit. So plus g prime is 14x cubed times x to the 4th plus 5 to the 5 halves. But we also need to bring in this x to the 3rd, so times x to the 3rd. And we can combine these two. 3 plus 3 is 6. So our final answer is 3x squared times the quantity x to the 4th plus 5, all of that raised to the 7 halves, plus 14x to the 6th times the quantity x to the 4th plus 5, all raised to the 5/2. And that is our derivative for A. All right, now let's do B. B, we're told to find the derivative of negative 4 e to the x squared. And anytime we have e to the x squared, we take the derivative of the exponent, and then the exponent stays the same. So if we take negative 4, the derivative of x squared is 2x, so negative 4 times 2x, e to that x squared, because that exponent doesn't change for e. So if we combine terms, we get that the derivative is negative 8x e to the x squared. All right, we're making pretty good progress. Let's do C. C, we're told that the function is the natural log of 5x plus 3. Now with the natural log, the derivative is 1 over whatever we're taking the natural log of, but we have to remember to apply the chain rule here. So our derivative becomes 1 over that original function, 5x plus 3, and then we multiply by the derivative, which is 5. So cleaning this up, we have 5 over 5x plus 3, and that's our derivative. All right, we're going to clean the board and keep moving. All right, now that we've cleared up some space, let's work on D. Our function is 3x over x to the 5th, or x plus 5. We have a pretty clear quotient rule. And so I'm going to tell you how I remember the quotient rule. It's low, d high, minus high, d low, all over low, low. Another way that we see it is if this is f and this is g, we have g f prime minus f g prime all over g squared. Whichever device helps you to memorize it, I just like the rhyming. So let's do high, d high, we'll make a reference box over here, low, d low, so we can fill all this in. Our high is 3x, the derivative of that is just 3, and then low is x plus 5, the derivative of that is just 1. So we'll fill this in, low just becomes x plus 5 quantity squared. Now low is x plus 5 times the derivative of the high, which is 3, minus high, which is 3x, times the derivative of low, which is just 1. So we're going to clear that out. And then we're going to distribute. We're given that. Next, we get the 3x plus 15 minus 3x over x plus 5 quantity squared. These two terms combine to 0, so our final answer is 15 over x plus 5 quantity squared. That's our derivative for D. Now E is a trig function. We also have the chain rule here that we need to watch out for. So our function is sine to the 4th of x. We're going to use the power rule, and then it becomes 4 sine cubed of x, and then we multiply by the derivative or cosine of x. Now f, our last one, is going to take a lot of unpacking because we have a lot of different parts here. Look at all that. So we're going to start outside and work inward with the chain rule. So our first is cosine and then the inside. So we take the derivative of cosine is negative sine. And then the inside stays the same, ln of 5x cubed. And then we've got the chain rule, so we're going to multiply by this ln of 5x. And the derivative of that is, so multiply by 1 over 5x cubed, pardon me. And then we multiply by the derivative of the interior function here, this 5x cubed. And the derivative of that is 15x squared. And we've got some canceling that we can do here. The 5 and the 15 reduced to 3. And then we have 2 x's in the bottom and 1 below. So when we combine everything, we have negative 3 sine ln 5x cubed, all that over x.